In this lesson, we'll be making conjectures using inductive reasoning. Let's define conjecture. A conjecture is an opinion or conclusion formed on the basis of incomplete information. We'll be forming conjectures based on inductive reasoning, which is a logical process in which multiple premises, all believed true or found true most of the time, are combined to obtain a specific conclusion. Let's take a look at the first example. Leela studied the following 5-year chart for total precipitate in Vancouver. Starting at the year 2003 and finishing in 2007, the precipitation for the months of January, February, up to December was measured in millimeters and put into this table. What conjecture could Leela make based on the data? Now there are a couple of relationships we can make in a table. A vertical relationship and a horizontal relationship. This means that we could find the average or the total amount of precipitate for each of the month, or the total precipitate or the average precipitation for each year. What I'm going to take a look at, and what interests me in this case, is the precipitation for the months of July and August. Just by looking at the numbers and compared to the precipitation of all the other months, it seems to me that July and August have the least amount of precipitation. So that's what my conjecture will be. That July and August have the least amount of precipitation. The next step is to use inductive reasoning to prove or disprove my conjecture. And how I'm going to use inductive reasoning is through the process of using the numbers inside the table. And I'm going to use the word sum. We're going to have the sum for all the months to the span of the 5 years. So when you add all the numbers up for July and August, we will get 157.4 millimeters for July and 121.7 millimeters for August. So those are numbers for July and August. We didn't prove yet that July and August have the least amount of precipitation. What we'll have to do is find all the sums for all the months. And here are the sums. January sum is 1003. February sum is 315. March is 649. April is 439. May is 241. July is 238. September is 237. October is 716. November is 888, and December is 828. So notice that my conjecture is true, or valid, because those months have the least amount of precipitation compared to all the other months of the year. Let's take a look at the next example. In this example, we're going to make a conjecture about the product of two odd integers. Before we jump into the question, let's understand the question first. Now, the word product identifies with the operation of multiplication. Odd tells us that the ending of the number has to be 1, 3, 5, 7, and 9. And an integer is a positive, and that's what plus v means for shortcut, and negative, that's what negative means, minus v for shortcut, shorthand, a whole number, that it cannot be a decimal, a value. So we're going to use inductive reasoning to insert, notice the keyword in, some values. For example, let's multiply positive 1 and positive 3. Positive 1 and positive 3 are both odds, and they're integers. If we multiply them, we get a 3. How about negative 1, which is also an odd integer, and a positive 9, which is also an odd integer? We'll get negative 9. How about negative 2 and negative 3? Well, we can't use negative 2 simply because it's not an odd integer, it's an even integer. Okay, so maybe those are bad examples. So we'll use negative 7 and negative 5. Both of them are odd, and both of them are negative in this case, which is fine. We get 35. So let's take a look at the answers to these. Now, how are these, the 3, negative 9, and 35, these values, related to one another? They're all odd. One of them is negative, so they have to be also an integer. So also are integers. So from this, we can come up with a conjecture. So the product of two odd integers is an odd integer itself. This would be our conjecture. Let's take a look at the next example. Make a conjecture about the difference between consecutive perfect squares. Again, before we jump into the question, let's define some words. Well, the word difference defines the operation of subtraction. Consecutive means next. And perfect squares means that a whole number that is squared. The next perfect square is 1, not 2 squared. And the next one is 3 squared. Next one is 4 squared, and so on. So in order to come up with our conjecture, we need to again use inductive reasoning. Again, the word inductive means that we're going to be substituting some values into our question to come up with a pattern or a conjecture. So let's take the first pair. 2 squared minus 1 squared, because that's what the difference between consecutive perfect squares. And 2 squared is 4 minus 1, that's 3. Keep going with the next pair, which is 5. The next pair, and that is 7. The next pair, and that is 9. So here is our pattern. Notice that the numbers increase by a value of 2. That's one way to look at the pattern. But also identify that if you look at the digits 2 and 1, we'll get 3. 2 plus 1 is 3. 3 plus 2 is 5. 4 plus 3 is 7. And 5 plus 4 is 9. So, in other words, if we have 2 squared plus 1 squared, and we square root both of these values, then we'll get 3. How does that work? Well, 2 squared, and you square root of that, that's 2. And 1 squared, and you square root that, that's 1, and we'll give you 3. Same thing we could do with the idea of 3 squared, the square root of that, plus square root 2 to the power of 2. And we'll get a 5. So based on this idea, we can come up with conjecture. The difference between consecutive perfect squares is the sum of their square roots. Now let's take a look at our next problem. In this problem, we will make a conjecture about the shape that is created by joining the midpoints of adjacent sides in any quadrilaterals. Again, before we jump into the problem, let's identify the key words that we need to know. Midpoint and adjacent side, as well as quadrilateral. Quadrilateral, if it's a four-sided figure. Adjacent side, it means that sides that are next to each other. Next to. And midpoints is a point that lies halfway between beginning and end of a line. So if this was a line, and A was beginning and B is the end, a midpoint, M, would lie somewhere in the middle of it, dividing the line segment into two equal parts. So now what we're going to do is we're going to join these midpoints of each of these lines in a quadrilateral. So the midpoint right here for this first shape. There's a midpoint right here, right here. Again, this is just a rough sketch. This means that A is divided into two equal parts. So is B. Notice the little three ticks identify that each side has a specific division that is equal because of the midpoint. And I'm just going to make sure that the midpoints are specified a little bit different than the divisions of the two lines. And we're going to connect the midpoints together. And we'll do a rough sketch on the other graph as well, on the other picture as well. Now what do these shapes look like? Well, these shapes look like a different quadrilateral. This quadrilateral looks like a parallelogram. So my conjecture would be that the shape that is formed is a parallelogram. So the conjecture is the joining the midpoints of adjacent line sides in any quadrilateral produces a parallelogram. So this would be the conjecture. Now in order to prove that this is a parallelogram, we have to do a couple things. We will have to prove that the opposite sides are parallel. And also we have to prove that not only are they parallel, but they're also congruent. That means equal in length. The way we do that is we have to measure the opposite sides to see if they're equal. And we have to also measure the angles that are opposites. If these angles are the same, and as well as the opposite side angles are the same, then the shape would be a parallelogram. So you have to use a ruler to find the opposite sides that are equal, as well as the opposite angles have to equal, and therefore it's a parallelogram.